Assalamualaikum warahmatullahi ta'ala wabarakatuh. Now I want to presentation about my paper. The title is Autonomous Museum Tour Guide Robot with Object Detection Using TensorFlow Learning Machine. The introduction. According to data from the Department of Culture, Tourism, Youth and Sports Sumeneb Regency in 2017 per June to July 2017. It has been now that the number of visitors to the Sumeneb Village Museum has the less number of visitors compared to other tours. This data indicate that museum tourism enthusiasts are still considered less attractive and less accommodating to the interests of visitors. Technological innovation, which is implemented directly at the museum, become a new attraction and technological renewal in the museum. Robot substitution to help tourists can be a solution to problems that occur in the museum in its development of the tourism sector in Madura in field of the technology. This is the method. In this paper, I'm using the CNN method. Making a CNN model requires a CNN network architecture which consists of several parameters, namely the filter in CNN is a weak metric which with its help can perform the convolution process on the shapes or that will be studied by CNN. Stride is a parameter that determines how much the filter shifts. If the stride value is 1, then the convolution filter will shift by 1 pixel horizontal and then vertically. The smaller the stride, the more detailed information we get from an input, but require more computation when compared to a large stride. Padding is a parameter specifying the number of pixels to be added on each side of the input. It is used for the purpose of manipulating the output dimension of the convolutional layer. TensorFlow is a library or software library developed by the Google Brain team by the Google Machine Learning Research Organization for the purpose research machine learning and deep neural network. TensorFlow then translate computational algebra compilation optimization techniques, making it easy to calculate many mathematical conversions by saving the time required to perform calculation. This is the robot autonomous museum tour guide. This study used an experimental method by testing the system on the prototype made, where the system reading data is in the form of object detection by the camera, which is then translated into input to move the motor as robot motion control. The data is processed using modified algorithm and system design calculation. The design of the autonomous museum target robot consists of mechanical, electronical, and method design that will be used by the robot. The following is the design of the robot that has been made. Mechanical design is a temporary design process of the system to be made, and this is the figure of robot autonomous museum circuit. In the number 1, the top section, this section is useful as to place the camera and speaker. The number 2, external rotary encoder. This device has an important role to build trajectory mapping system on the robot. In the number 3, OmniWell sensor. This well is used to drive the rotary encoder sensor to movement of this well follow every robot movement. And number 4 is OmniWell. Number 5 is OmniWell motor. And number 6, camera. And number 7, audio speaker. This is the table of marker image dataset. The red circle is robot stop, and yellow circle right turn robot, and green circle left turn robot. And the number 4, the name is Bokor or Cemong in Indonesia. Robot stop and play audio explanation legs if the robot detect this Bokor. And number 5, Kecohan, the name of Indonesia. Robot stop and play cheat explanation audio. And the last, Inchins container. Robot stop and play sensor container explanation audio. This is the museum tour route simulation. From figure 4, it is now that there are 3 collection rooms, and in each room has 1 collection item. The robot will start moving at predetermined gathering point, which will then move into the museum by continuously detect objects around it. Along the route, marker will be installed that can be detected by the robot, so that the robot can decide which command to take, including walking straight and turning right, turning left, or stopping to explanation information about collectible, and the other explain. This is the work system flowchart. We start from the user process on the button start on, and the last audio motor off. After that, this robot can detection marker in museum. CNN learning subprocess. This is the flowchart of CNN learning in the subprocess. Start from marker image dataset until convert to protobuf. Simulation of convolutional neural network method. In this process of simulating the calculating of the CNN method, there are several things that must be done beforehand, such as making a CNN architectural model and performing calculation on each training process on CNN. This is the CNN architectural modeling, and then this is the fully connected layer network architecture. And the result collect and make dataset in the form of image obtained from the museum. The point A is the pre-processing and processing of input data, and point B, this is the training process. This is the table CNN model structure. And from layer input, convolution layer, max pool, convolution layer 2, max pool 2, and fully connected edge and class. This is the output. Pixel size is 228. This is the result. Graphical training accuracy chart and error training graph. The test result and evaluation. This is the tables and network training result from the iteration 1 until iteration 175. Accuracy 100% from the iteration 175. This is the data validation. This is the data validation. And then this is the CNN implementation on robots. And this is the detection result from the robot detect. Object detect, number 1, this is good lighting. The actual response is robot stop and success percentage and 100%. All of the condition. Object can detect with a robot, and then robot stop, the success percentage 100%. The conclusion of this paper, the process of detection objects that are in the database will be detected in real time using a camera implemented in the robot by showing satisfactory result with the system test, which produce good accuracy. The application of the CNN method in recognizing objects in the museum is very good and running well. This is evidenced by the obtained validation result of detection data reaching 97%. The training process used the Foster R CNN method with a data set in the form of image that have category from the SIG object detection classes and become an alternative reference for detecting and classifying objects so that the results obtained are maximum and more efficient. And the next, the robot success in detecting 6 objects at the Sumnapalist Museum, which were integrated into a robot with 100% success. In the fifth epoch, with the 175 iteration, the time required was 117.11, error 0.393. And the last weakness in the study are the need for a control over the course of the target robot so that the robot runs more stable, and the use of a camera with a higher resolution but when run on the system doesn't affect system performing. This is my presentation about this paper. Thank you very much for attention. Wassalamualaikum warahmatullahi wabarakatuh.